kids, Miss Block here, and today we're going to continue our journey through surface processes by examining erosion and deposition via gravity, aka mass movement. You should have your notes, earth science reference table, and something to write with handy. As always, you can pause and rewind or rewatch this video in its entirety to review any concepts that you might not have understood the first time going through, or anything that you might have missed. You ready? Let's get started. So we've been talking about weathering, which is the breaking down of rocks into sediments, and then we talked about transporting those sediments via erosion, taking those sediments from one location to another. Then we discussed dropping off or depositing those sediments through deposition. Now, we're going to look at 4 ways that our sediments can be eroded and deposited. And these are the 4 that we're going to examine throughout the course of the rest of the unit. These 4 types are gravity, aka mass movement, running water, wind, and glacial, aka moving ice. This video is only going to look at one, gravity. Now, it's important to note that gravity is the driving force behind all erosion. However, it is not the largest or most influential agent of erosion. That would be running water. But gravity is still important, also known as mass movement. Now, gravity erosion is known as mass movement because we're moving large masses of sediments from one location to another, sometimes very slowly, sometimes rapidly. Now, gravity erosion is the downward movement of soil directly caused when gravity overcomes friction. So right there, those sediments are stuck due to friction, but sometimes due to outside forces like shaking due to an earthquake or excess moisture from heavy rains, they can start to move and then slide down in an avalanche very rapidly, or they can move very slowly like soil creep. You can see right here from this diagram taken directly from your notes, I did not create this diagram, we can see that they can move slow, imperceptibly, you can't see it happening, such as soil creep. And as we move over to the right, they move faster and faster, such as a rock fall or debris fall, known as a landslide or avalanche. It is important to know with gravity erosion how the sediments appear, so you can tell that gravity erosion or depositional systems taking place. So these sediments will tend to be unsorted at the base of a cliff right here, and they'll be very angular in shape. So they're going to be unsorted and angular, just like in this picture here. So there doesn't seem to be any pattern right here of deposition. They're just all over the place, and they haven't been weathered that much. So they haven't been weathered by abrasion. All right, they don't have that rounded or smooth look. All right, so make sure you realize they are unsorted and angular in shape, aka talus. Be sure to review in your notes what types of soils will slide easily and what types of soils won't slide easily. Hint, 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 if there's a lot of vegetation present, those soils will not slide easily. I hope you were able to get a lot out of this video. Gravity erosion, not much to know as much as, say, glacial and running water. Be sure to review those videos very heavily. I'll see you soon, maybe in extra help. Take care. Bye-bye.